Now we come to the study of analysis of fifth group. So we take fourth group filtrate and boil off H2S from it. The solution thus obtained is taken and add ammonium carbonate to it. If a white precipitate appears, it means fifth group is present. This precipitate may be of barium carbonate, BaCO3, strontium carbonate, SrCO3, CaCO3, that is calcium carbonate. So we collect this white precipitate and dissolve the precipitate in acetic acid and proceed for testing in the sequence. This is very important. Barium ions, then strontium ions, and then calcium ions. So we take this solution which has become colorless, take one part of it and add potassium chromate to that. If a yellow precipitate is obtained, that confirms the presence of barium ions, because this yellow precipitate is that of barium chromate. Filter it and use the filtrate for testing strontium ions. For that add NH4 whole twice SO4 to it. A white precipitate of strontium sulfate confirms presence of strontium ions. So filter it and then to the filtrate add ammonium oxalate solution. If we get a white precipitate of calcium oxalate, this confirms calcium ions. If you are given a single salt, then divide this solution into three parts and test one part for barium ions, second part for strontium ion, and third part for calcium ions, as suggested in the adjoining scheme. Another test for these radicals is flame test. The colors of flame obtained are barium apple green, strontium crimson red, calcium brick red. Reactions and explanations for group 5. BaCO3, SrCO3 and CaCO3 all are white insoluble in water, hence appear as precipitate on adding ammonium carbonate in basic medium. But these are soluble in acid medium. For this purpose, these are dissolved here in acetic acid, where they form soluble acetates. So let us first discuss barium ions. Barium ions directly from the salt solution or from barium acetate solution. To that add potassium chromate. So chromate ions combine to give barium chromate, a yellow precipitate. At this stage, the solution may have Sr2 plus and Ca2 plus also, but their chromates are not precipitated because the solubility product Ksp of barium chromate is much less than the chromates of strontium and calcium. Well, next we discuss Sr2 plus strontium ions. After filtering barium chromate, the filtrate may contain strontium ions and calcium ions. To this we add ammonium sulfate, then strontium sulfate is precipitated as white precipitate. Since Ksp of strontium sulfate is much less than that of calcium sulfate, hence only strontium sulfate is precipitated. There is no risk of precipitation of barium sulfate because we have already removed barium ions as barium chromate. Finally, we have calcium ions. After filtering strontium sulfate, the filtrate may contain only calcium ions. For their precipitation, we add ammonium oxalate, NH4 whole twice C2O4. Thus calcium oxalate CaC2O4, whose Ksp is very low, is precipitated as white precipitate. Analysis of group 6th, that is test for magnesium ions. Either take filtrate of 5th group or we may take the aqueous solution of the salt directly. To that add ammonium hydroxide in excess and then add disodium hydrogen phosphate. A white precipitate appears. The first reaction is magnesium ions aqueous or the directly salt solution plus ammonium ions plus HPO4 2- form MgNH4PO4, a white precipitate of magnesium ammonium phosphate. The second reaction is Mg2 plus aqueous plus Titan yellow, that is an organic dye. Little NaOH must be present. We get a red color or the precipitate. Titan yellow is also known as Clayton yellow. It is a water-soluble yellow dye stuff. It is adsorbed by magnesium hydroxide producing red color or the precipitate.